So welcome back to calculus. In this lectures, we're going to learn how to use the sum and also the difference rules to find the derivative of a function. So if a derivative of a function is given, for example, here we have f at x plus g at x. To find the derivative of the sum of the two functions, we find the derivative of f, then we find the derivative of g. Or if we are finding the difference between f at x minus g at x, the derivative of it, we also find the derivative of f at x, then the derivative of g at x. So let's see an example here. A function is given which is f at x equal to s cubed minus 4x plus 5. Now, to find the derivative of this function, first we find the derivative of x cubed, which we use the power rule. So that will give us 3x squared. Then we find the derivative of 4x, which will give us 4. Then we find the derivative of 5. Again, we know the constant derivative is always 0. So our answer will be 3x squared minus 4x. Again, s cubed, we use the power rule. So that will give us 3x. The exponent to be 3 minus 1. Now let's look at the second example. We have a function g at x equal to negative x to the power 4 divided by 2 plus 3x cubed minus 2x. Now, to find the derivative of this function, again, we need to find the derivative of each term separately. So we have minus x to the power divided by 2. Again, s to the power 4, we use the power rule. So this will give us minus 4s cubed divided by 2. Now, 2 can go into 4, so we are going to cancel the 2. So our first term will be minus 2s cubed because we cancel the 2 with the 4. Then the next, we find the derivative of 3s cubed. That will give us 3 times 3. So that will give us 9x, then 3 minus 1. So that will give us 9x squared. So that is the 9x squared. Now to find the derivative of 2x, again, that will give us 2. We still use the power rule. Let's assume that s is raised to the power 1. So we get 1 times x, then to the power 1 minus 1. Now we know that any value raised to the power 0, again, is 1. So that's why if we have a derivative of a term 2x, our answer will be 2. If the x is to the power 1, the answer will be the constant value. The same thing in our first example, 4x, the derivative will be 4. Let's see one more example. Here we have y equal to 3s squared minus x plus 1 divided by x. We can rewrite this equation by dividing x to all the 3 terms. So 3s squared divided by x will give us 3x. Minus x divided by x will give us minus 1. Then 1 divided by x will give us 1 over x. So now we can find the derivative of this term. Now 1 over x is the same as writing x to the power negative 1. So we can use the power rule here. So the derivative of 3x will give us 3. The derivative of a constant value minus 1 will give us 0. Then the derivative of 1 over x will give us 1 over x squared, because 1 over x is the same as writing x to the power negative 1. So the power rule is we subtract negative 1 from negative 1, then we multiply negative 1 with x. So we get minus x to the power negative 2, which is the same as the reciprocal. We change the exponent to positive. So x to the power negative 2 is the same as 1 over x. Then if we like, we can combine this term here. We find the LCM, s squared, then we get 3 times s squared minus 1. Now, next example, to find the derivative of the following function, y equal to 3x plus 5. So again, we know the derivative of, again, 3x will be 3 and 5 will be 0. So the derivative of y at 3x minus 5, the answer will be, again, 3. B, we're going to find f at x equal to 4s cubed minus 2s squared plus 5s minus 3. So derivative of 4x cubed will give us 12x squared. Derivative of 2x squared will give us minus 4x. Then derivative of 5x will give us 5. And the derivative of 3 will give us negative 3 will give us 0. So that's both solution. The first one, we have 3 times 1 plus 0. The rate of a constant value is 0, so the answer is 3. Here we use the power rule, so we multiply 3 with 4, and that will give us 12 x squared. Then 2 times 2 will give us 4. 2 minus 1 will be x. Then the rate of 5x will be 5. So our final solution will be 12x squared minus 4x plus 5. So that will be the conclusion. Again, in these lectures, we go through the calculus derivative using both the sum and difference rules. Thank you, and see you in the next class.